Hi everybody, this is Purnima Magalingam and you're watching video lecture series on solar and wind energy. So today in this video, we are going to discuss about fixed speed wind turbine in wind generator topologies. In this video, we are going to discuss about the fixed speed wind turbine where the dominant technology until the early of 2000 and representing over 70% of installations before 2000s. They paved the way for modern variable speed designs. Come, let's go into the video. Here, here comes the wind speed. What about here it is? Introduction, the core of early wind power. So first one is constant RPM. That is fixed speed turbine operates at a constant rotor RPM. Here what is the next is the direct grid connections. Next one is aerodynamic control. This is what and about core of early wind power. Okay, here we can see the picture. What about it is constant RPM? The RPM must be constant and direct grid connections and aerodynamic control. The next is key component and operations. What are the key components needed and what are the operations? Okay, the fixed speed turbine primarily use squirrel cage induction generator. Their rotor speed is fixed by the grid frequency, which is typically 1500 or 1800 RPMs. Okay, slip is very smaller as the range is from 0.5 to 2%, and there is no complex power electronics in the main power part. Okay, this is what are the key components and operations. Now coming to what are the sorry. So grid connections and the challenges. What are the challenges we are facing? That is, first challenge is reactive power. They inherently consumes reactive power from the grid. And what is the reactive power? This is the main important plays an important role in power transmissions. And what next one is capacitor bank. So the large shunt capacitor banks are needed for power factor corrections. For power factor corrections, the capacitor plays a main role, and the voltage flickers. So it can causes voltage flickers due to the power fluctuations. Yes, of course, because of the power fluctuations, we'll be having the voltage flickers. This is indirectly it's a big challenge for correcting the grid and the mechanical stresses. So what about mechanical stresses? It is imposes a significant stress on drivetrain components. Yeah, sure. This is one important challenge. What are the challenges while connecting to the grid? These are the list of the challenges. What is the reactive power and the capacitor bank and the voltage flickers and the mechanical stress. Now coming to the advantages of fixing fixed speed technology. The first one is it is simplicity. The simple design and operations. Comes here, it comes as here comes here. It is simple design and operations. Main thing is simple design and operations, and it is reliability. And what is it? High robustness and reliability. It is this is the main thing, reliability and low costers. So the low initial capacity cost about 15 to 20% is less per megawatts. So we see that is 50 to 20% is less per megawatts and the mature technology. So manufacture mature technology with expensive. So these are what are the advantages of fixed speed technologies. Now coming to the disadvantages of the evolutions. So main is suboptimal efficiencies and what is in the inefficient in varying wind conditions. So in variable windy conditions, the efficiency gets decreases. This is what main disadvantages. Next one is high mechanical load. It causes reduced components like life during gusts. Okay. So next is poor power qualities. So limited grid stability supporters, limited grid stability supporters, and that is limited grid services. Here it has a limited grid services that cannot performance advanced grid services. These are what are the disadvantages and the evolutions. Okay, grid limited service can't perform advanced grid service. This is also main disadvantages for this. Next one is key fixed speed topologies. What are the key fixed speed topologies here? We can see it is by this diagram. It is so type one is squirrel cage induction generator. Main is squirrel cage induction generator. The next one is wound rotor induction generator. So here the squirrel cage is the most common type as type is direct grid connections, which is the example of right this and this with external resistance, the limited speed variations, which is smoother startup example, early Nordex model. These two models are key topologies, means fixed speed key topologies. Here you can see this is squirrel cage induction generator. Here this is what is squirrel cage induction generator. This is what an wound rotor induction generator. So you can see the pictures. You can see that. Now coming to the conclusion of this is a foundation of wind energy. So what conclude here it is an essential historical role in commercial wind power growth. Yeah, it is an essential historical role and lesson learned here this shape model wind connector grid code requirement. Here this still present in older wind form. Here still present in older form about 10 to 15% per 2500 feet. Okay. So simplicity and robustness remains valuable design principle. This is what is simplicity and value robustness remains valuable design principles. From this, we are concluded these 4 points. And thank you for watching this video. And we'll meet with another topic. Thank you so much. Bye bye.